One of the questions I often get asked from customers is how many assets should be connected to their smart factory solution? This can be a difficult question, one that is wrapped up in the decisions around potential use cases, different technologies, and the myriad of different vendors in the smart manufacturing landscape. For a detailed discussion about these higher level questions, there are several other webinars and articles I've published before on getting started with Industry 4.0, bottom line impacts of Industry 4.0, smart factory impact on operational KPI, and more. For today, I'll assume those questions have been answered, and now it's time to determine the scope of the implementation within the plant. As a quick procedural note, if you have questions during the presentation, please enter them into the Q&A, and I will get to them at the end of the webinar. Thank you. So what drives the decision around scope within the plant? What are the key factors to consider? Here's a good list to start with. First off, always begin with value. The overall benefits to be received will be the primary driving factor in the scoping discussion. These business case studies should be performed in a way to create a complete roadmap instead of being used to justify a single initiative. This roadmap will lay out the desired end state when it comes to functionality. There are some portions of the cost that are constant across the plant, example, software licensing, and parts that scale with the number of assets connected if sensors or retrofitting are required. Also, time to value needs to be considered here, as it is often critical to get a rapid time to first value in these projects. And again, these webinars and articles referenced earlier go into a lot of depth on the business case and the roadmap analysis. The roadmap will also be used to drive use case selection. The key here is whether the implementation will be focused on a single use case, or is it being looked at as a transformation effort? While the single use case is likely to be centered around a particular group of assets, the transformation project should be inclusive of most assets in the facility, even HVAC. I recognize that this is more of a spectrum than an either or choice. The endpoints are very clear. It is the middle that often seems like a gray area. At the risk of spoiling the rest of the presentation, most of the time, the default should be to connect to as many assets as possible. The next item to consider is which assets or resources are going to need to be involved in the implementation. To drive long-term success, it's important to involve as many stakeholders in the implementation that will be impacted by the project. At the very least, each person should be impacted, or that will be impacted downstream, should get visibility and a representative colleague involved in the actual project team. For smart factory implementations, this list can grow quite large. Operators, production management, process engineering, continuous improvement, quality, and IT should all have representation in a full factory implementation. When the scope is limited, it can obviously be a much more limited group of people that will be involved in the project. It's important that those people get visibility because we'll be asking everyone to change how they do work to utilize the capabilities of the new system. As a result, the readiness of those resources for the change is critical to determining scope. If the computer skills of the workforce or their sophistication for interpreting data are lacking, that should shape some of the decisions made around the implementation. It may not mean that change should not be undertaken. It may just mean that more time needs to be allotted to upskilling the workers. Another factor to consider is whether the continuous improvement infrastructure is in place to utilize the information coming from these systems to make the process better. After all, collecting the data and presenting pretty charts and graphs alone doesn't make machines run more often. Somebody still has to use the data to make changes to the process. The final factor to consider in this list is the impact on production these projects can have. For plants with older equipment that may need retrofit that may need to be retrofit with new controllers and additional sensors, this might mean taking those machines out of production while the retrofit is happening. This can be a big impact to the plant and a large hidden cost of the project. The same with the need to take workers off the line to provide them with training on new software, hardware, or standard work. Again, this doesn't mean that the transformational approach should be avoided. It just needs to be considered and included in the project planning. With all that said, when does it make the most sense to perform a tight, focused implementation and connect just a few key assets? As I'll show in the following slides, there are select circumstances when this is the case. Let's explore a few of them. The first example of connecting to just a few assets is when performing a technical proof of concept. In this particular case, the emphasis is on whether the technology will work with the company's environment. This is much different from a POC or a pilot where the company is trying to prove out the value attainment, which I'll discuss later. For this effort, the scope is to validate the following all function as promised by the vendors. This is not a comprehensive list, but it's a good start. Sensors, data collection from the sensors, machine controllers, et cetera, networking within the plant, networking to any cloud-based portions of the solution, bandwidth, data storage, cybersecurity, reporting, workflows, integration. This effort is deemed a success if the test plans for each one of those different elements is passed. The project should not only have a limited scope in the number of assets to be connected, but should also be time limited so that the company can move on to the full scale implementation. The next example is when there's an issue in the plant that's a burning platform that has to be fixed. In this case, the company isn't trying to transform the way that manufacturing happens. They're just looking to solve one particular problem that is costing them a lot of money every day, every month, every year. This could be a downtime issue, a quality issue, or other type of problem, but it's persistent and the company is looking for a solution. Usually, this type of situation only exists on a limited number of assets. If all the machines were giving this much trouble, nothing would ever get built. Many plants have this type of a problem. There's a set of machines that becomes the constraints to manufacturing output because they just can't stay running. Maintenance has worked on those machines for years, as has engineering. The vendor has been involved, but the machines are still just having major downtime issues. The next step in these cases may be to implement a system that pulls information from those machines to provide additional diagnostics and monitoring, perhaps even predictive capabilities. When the scope is this tight, the number of people involved in the project can be limited. Only the people that work with those machines need to learn the new solution and how to use it to improve the process. As a result, it does not require changes to the overall processes in the plant. The people working with those machines are highly motivated to use the Smart Factory solution, though, because the machines have been such a large issue for such a long time. They're willing to use a different solution because most of their job is focused on keeping those problem children in line. Predictive maintenance projects are often a great example of Smart Factory issues targeted at fixing problems on a limited number of assets. As an example, I have a customer in the automotive industry that has a mill that had been costing them over $5 million in repair costs every single year. And that doesn't even include the lost revenues from all of the downtime. When they were looking at Smart Factory solutions, they were absolutely laser focused on what would help them keep that one mill up and running more effectively. More broadly, it sometimes does not make sense to implement predictive maintenance solutions across all of the assets of a plant. Simply put, improving the performance of many pieces of equipment does not provide enough payback to justify the investment. The focus for these implementations is on a couple of scenarios. The first is on constraining assets where the output of the plant could be increased if those machines could be kept running more effectively. And the second is on those machines where maintenance costs are particularly high, such as my automotive customer mentioned earlier. Predictive maintenance and quality, as I'll talk about in a few minutes, is somewhat unique among the Smart Factory solutions. The number of people interacting with those systems is usually limited. Depending on the solution chosen, there may require a significant amount of expertise to get good results from the models. This could involve data science people within the organization or external consulting personnel. They can be very beneficial, but they're generally also isolated systems. Predictive quality projects are very similar in nature. These are typically implemented in processes where the company is looking to identify causes of variance in production. They may believe that certain input or process variables will serve as leading indicators for quality issues in the product. This is also usually an isolated project instead of being a broad-based across the plant. So let's take a look at the other end of the spectrum. When should the company connect all of the equipment, or at least the vast majority of it? In my experience, anytime the company is implementing a system such as OEE systems, IoT systems, or other cases where process and behavioral change will be required to get the value from the solution, it makes most sense to go broad. This was the center of the webinar from 2 weeks ago on driving long-term value from IoT. Without repeating everything from that talk, here are some of the key highlights. When implementing use cases, hoping to drive long-term transformational change in the factory, the focus is on use cases, the focus on the use cases needs to be more broad than simply putting a data collection system in place. The focus shifts from the technology solution to the people in the organization. What can be utilized from the new solution to enable them to be more effective, produce more, and have increased job satisfaction? How can these systems help orient people towards taking action? After all, that's the primary goal we're trying to achieve through the transformation, not to show the pretty charts and graphs. Finally, thought should be given at how to share information across the different systems, and I'll cover this in more detail later. The other main tenet from the previous webinar was around getting adoption of these systems on the shop floor. Getting widespread adoption of these new solutions generally requires cultural change on the shop floor. This is extremely difficult to achieve when the software is only on a limited number of machines. As an example, against my recommendations, I had a customer implement an IoT solutions on 2 assets out of the hundreds on the shop floor. The operators rotated through those stations throughout the day, and the machines were a very small portion of that area's supervisor's responsibilities. For the engineers and maintenance people, those were just 2 machines out of the entire plant they had to support. While the project was a technical success, the people involved stopped using the solution shortly after it was put in. Their standard work was built around the machines that did not have the IoT system in place, so they didn't use the solution at the other machines. After a few months of this, I was able to show management that the software was doing exactly what it was promised, or what was promised, but they needed to implement more broadly and adapt the standard work for everyone to incorporate the solution. And they're now a great success story. These solutions often require additional skills from the workforce that just don't get prioritized when the systems are on a limited number of pieces of equipment, or it becomes a hurdle when trying to cross-train workers to rotate between jobs. Having a common system, a common approach, and universal standard work can help adoption tremendously. When implementing Smart Factory, the goal should be to create an initial baseline of functionality where the systems are connecting to the machines, collecting the data, and storing the information. From there, a near infinite number of capabilities can be layered on top to transform the factory. These can be thought of as layered sprints, adding additional functionality 1 piece at a time. The best part is, while the value from the implementation continues to grow, the costs of the software and the hardware remain relatively fixed. There's a positive ROI from the initial implementation, but the long-term value explodes as layers are added. Over the next few sections, I'll touch on each one of these topics. Once the data is persisted, updating how manufacturing data is reported is one of the first steps to take further advantage of the new capabilities. These are just a few of the examples of what can be done with the information available through these systems. For one, much of the manual data collection and reporting that happens in manufacturing today can be eliminated. For example, the collection of downtime information on paper tick sheets or in Microsoft Excel can be eliminated. The data can be collected directly from the machine with some light additions from the operators when necessary if the machine doesn't have the reason for the downtime. Since the information is being bottled at the source in real time from the machines, it can also be displayed on the shop floor in near real time as well. This can be used to just replace paste boards, SQDCM boards, or other visual controls that are maintained manually on the shop floor today. This information can be used for real-time management and reporting. At a simple level, this can be used for providing visibility to real-time status and performance inside the offices. At a deeper level, it can be used for things like real-time cost variance and combined with financial data. Period KPI reporting can also be automated. Whereas today it takes a number of people in the plant to compile data into an array of Excel reporting for KPIs, that can pretty much all be automated when the data is available. This really highlights why it is so valuable to get nearly all of the equipment on the same system, because you can automate the whole thing that way, as opposed to still having that manual process to get the information from some parts of the plant. Finally, this can be a big part of any paperless factory initiative and getting rid of all of those manual tick sheets and so forth. Also, when the whole shop floor is connected, there are a huge number of possibilities that open up when combining shop floor data with other systems. This is not anywhere close to an exhaustive list, but it does give a great idea of how transformational it can be when all of the machines are reporting data. So the maintenance management system, connecting the information from the machines to the maintenance management system enables a lot of additional capabilities within manufacturing. One example is to present autonomous maintenance checklists to the operator each morning or whenever the task would be due. This works best when there's a common process, no matter who is working at which machine that day. By including work instructions for the tasks, it can greatly simplify job rotations and having people step in for absent workers. These systems can also be combined to analyze preventive maintenance plans. The goal is to do enough PM tasks to keep the equipment in optimal condition, but not to do any more than is absolutely required. The combination of these systems can be used to continually monitor the PM schedule and analyze what should be done more or less frequently, and what should be added or what should be eliminated. They can also be combined to automate the ticketing system, and that response when there's an outage on the shop floor can be greatly sped up, as I talked about in my talk on minimizing the mean time to repair. Another piece of analysis that can be done with the information from the two systems combined is spares and tooling management analysis. The data can show how much stock to carry in much greater detail than the MMS system alone. In addition, if predictive capabilities are incorporated into the implementation, the spares required for the predicted failure modes can be ordered in advance of the need on the shop floor. The quality management system. As with the maintenance management, there are a myriad of potential touch points between the shop floor data and the QMS system as well. I'll touch on a few of those here. Some of the items listed here are similar in nature. When researching causes for quality issues, everything actually is quality data. That includes machine production, or machine data, production data, testing information, and much more. This can be used to automate the CAPA reporting into the QMS, provide support for analyzing causals for the quality issues, and support design of experiments or analysis of variance studies. If that last topic is of interest, by the way, join us on 4/20 for our webinar Wednesday when we do a deep dive on that topic. Additionally, the systems can be combined for quality documentation as well. So for example, the information from production tests and inspections can be automatically gathered into a certificate of compliance to ship the product out to a customer that requires such documentation. ERP and financial systems. There are many, many examples of what can be done with this integration that are not listed here. This is only a taste of what's possible. First off, the information from production can give finance complete visibility into the tasks, material, and resource consumption in manufacturing. This can help them generate a real-time cost variance analysis or alter how they perform allocations to be based on the actual data from the shop floor. Inventory tracking can be significantly eased by automating the tracking of material movement within the factory. And in addition, data can flow the other way to provide business context in the shop floor reporting. For example, downtime and quality issues can be dollarized so that people can see the costs that are associated with those issues and prioritize the response accordingly. Planning and scheduling can be significantly improved with the data from the shop floor. Scheduling is extremely sensitive to the starting conditions in the facility. These can be set precisely when all of the equipment is reporting its current status through the Smart Factory system. Additionally, the amount of runtime required for processing different tasks can also be captured in great detail through the Smart Factory solutions. This will help increase the quality of planning by quite a bit versus the standard times that exist at many companies. Reporting can also be done in real time for schedule adherence, and the upcoming schedule can be displayed on the shop floor. Combining these systems also creates the possibility of closed loop real-time planning systems that are completely adaptive to changing conditions on the shop floor. These types of planning systems are not possible without having the complete shop floor wired into the Smart Factory solution. From a facilities perspective, a couple of quick hits here. The first is being able to track the environmental impact on manufacturing. I've worked with a number of companies whose production is extremely sensitive to conditions such as humidity. Working with a spice manufacturer, we performed a study on the impact of humidity on their filling operation and how to adjust for clumping at different humidity levels. Another example in the food industry is the need for cold chain certification for certain products. Monitoring the readings throughout the facility and being able to document where the product was at all times is critical to automating that process. For engineering, there are a lot of details behind this, but combining a company's Smart Factory systems and their product lifecycle systems and CAD and other engineering systems allows for significantly enhanced design for manufacturing or design for Six Sigma processes. Just one example of the potential interaction is the automation of product FMEA data collection. And even something like customer service. Warranty data is often analyzed on its own, separate from the information from production of when those goods were produced. By combining these systems, correlations can be found of which factors in manufacturing are predictive of items that end up in warranty downstream. Likewise, the information from the field service group in the call center can be used to identify where manufacturing processes may need to be adjusted. And finally, using the layers we added earlier for data reporting and integration, we can create some very advanced workflows to support previously manual processes in the plant. I've done detailed webinars and articles on each of these, so I won't go into too much detail here, but these are very powerful capabilities that can help a company become a true world-class manufacturer. Automating visual controls on the shop floor can help reduce many forms of waste while influencing the behavior of the people in manufacturing in the desired directions. Problem-solving skills are at best uneven among the people in many companies, and by creating workflows that automate many of the portions of data collection and analysis, it can raise the effectiveness of everyone in the entire organization. Digital management operating systems can create alignment from the executives all the way through the shop floor. They can mirror the policy deployment process in the company and enable everyone to see where they stand at all times to see if they're winning or losing that day, week, month, and year. Value stream mapping can be largely automated with the data in these systems instead of valuable process that is done once in a while and then put into a drawer. The value stream map can become a living management tool that can show current performance of manufacturing against what's documented in the VSM. Oops, sorry. Similarly, the failure mode and effect analysis systems can be created that utilize the information from the shop floor to populate and update the failure modes, the probabilities of failure, and more. In the other direction, the FMEA analysis can help determine the data that should be collected from the machines to maximize the probability of detection and to identify recommended actions where particular failure modes are observed. And these are just a few examples. There are many more advanced workflows that can be created once that whole shop floor is connected. In summary, I generally recommend that companies plan to connect as much of the equipment as they can over time. Start by connecting the machines where the data and inherent functionality in the smart factory system will provide immediate value, but then plan to expand the data collection and layer on additional functionality over time. It makes sense to proceed this way because of the value of the additional use cases, the need for common standard work across the shop floor, helping to drive adoption and being able to reach those advanced workflows. That's it for today's webinar. In the coming weeks, we'll have a number of great topics on our webinar Wednesdays. Be sure to go to the Visual Decisions website to register for them today. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve continuous improvement since 2002. We help our customers combine the smart factory with the lean factory to drive improvements to cost, throughput, and quality. Thanks for joining us today. If you have questions or would like to talk about how to apply these concepts within your company, please reach out to me. If you can give us a call, send us an email, or go to this link to set up a meeting directly. We'd love to talk. Thank you very much.